Um, is this meeting being heard? Can you hear me? Thank you, thank you, thank you, thank you. Okay, thank you. All right. Hello, Rain. Hello, Dirkel. Hello, Robert. And thank you, and thank you, thank you. And hello, everybody. But strangely, so we're going to get to like physics. We're going to start ramping things up. Things are going to get a little bit, we're going to start moving, I think, a little bit more happily and a little bit more forwardly for a number of reasons. One thing is you're going to see if you got, so we're going to go to the math methods sheet. That's where we have been. In fact, I'm going to share it in a second, but we're going to go back to that math methods sheet. We talked a lot about F and G and what they meant for the phase constant. And then we got into the chain rule, which was cool. So now we're going to go to H, and H is going to be another little, like, let's be honest and see how much calculus we were actually okay with. So it's going to be directly about the math, maybe more than the physics. We might be stuck in math. But anyway, we're going to do H and all that and so forth. But we're going to do it in a slightly new way, a new way that you might have gathered from the two things that I put in the stream or in the assignment stream. I did put what looks like two new assignments out of nowhere in, it looks like two things that are due next week, and it may even look like, whoa, what? You're going to find in a second, depending on how clear they were if you read them, you're going to find that it shouldn't be stressful. Let me just ask though, can I just get, can anybody confirm that they did get two new assignments called like in the about 5 minutes before class today? The two assignments are called like a game, take one. Yes, thank you very much, Brianna. Okay, great, thank you. Now, as an example of how this game is going to work, and it's a game except it's reality, like just by virtue of answering that question the way they just did, Brianna and Dirkel and the people before, just by even putting the yes in the chat, they just in effect got 50 points of homework, homework points, which are significant and do get, I think, from Physics 203, like the homework points that you get, which I still owe you guys a lot of any homework you've done that you haven't gotten back yet, you're still going to get credit for, and and all gets added to your average at the end, and it makes a big difference in the grade positively. Well, I'm going to start shifting of the way we do those homework points. The whole point of those homework points is it's supposed to reward effort and engagement regardless of correct answer, right? Well, I want to shift that very explicitly and directly to class participation, like to the point where, so I'm right now about to explain what those two assignments mean. They're introductory assignments to this larger game I hope we're going to start playing in class, which is that at any point, if you make any contribution at all to the class discussion, any contribution at all, either with your voice or in the public chat, right? And any contribution could be literally like saying yes when I say, can you guys hear me? Because, especially if you say it fast, like it really shows you really are listening, and it blah, blah, blah. You do anything like that, and then you're going to remember that you did that. And at some point, maybe even in the middle of class when you're bored or whatever, you're just going to jot on a piece of paper, like, I'm the one that said yes when you, Yaverbaum, asked, can you all hear me? Okay, you're just going to remind me of that little contribution that you made. And you're going to take a picture of it and submit that as a PDF, as a one-page, one-sentence PDF to that first assignment portal that I just opened up, the a game, take one. Like literally anything you say at all or put in the public chat, you're just good, which I'll probably remember anyway and all that, but you're just sort of reminding me and connecting your name with your statement, and you're going to write down a piece of paper, and you will automatically I shouldn't say automatically, but you will then get 50 points, like a full 50 points, as though you just did a whole big problem set that's worth 50 points. And it will be worth the same 50 points that a long problem set would be worth, and it'll go on your grade and all that. And if you don't do it, you won't get the 50 points. I mean, no one's going to be punished or anything, but if you say one thing today, which like 6 people have already done, and like, as far as what I'm saying so far, like, this is how serious I am. They could like leave now and they would still get the points that I'm talking about. I don't want them to. Obviously, I want them to talk more. But just by virtue of saying yes in the public chat when I said, can you all hear me? Each one of them can write that on the piece of paper, submit it for assignment 1, boom, and I'll see it later. It'll remind me, and they'll get 50 points. More important, they'll be just cementing more the name, face, personality connection, cementing in my mind the connection of who they are, which is like helpful to everybody and everybody's grades. Okay, but now there's a second piece to it. I'm going to keep going because this is the way it's going to be. And we're going to do this, like, I'm going to start throwing more questions at all of you all to solve together. But any contribution anybody makes to public chat or to speak is point worthy, period. But now let's go a step further. Let's say as we get rolling here today and we start going over like a question that I'm going to give you,
almost done. I know it's a long time.
Oh, wait. Oh, my God. Sorry. I was about to say someone's.
I want to hear the answers from you guys. What you're seeing on the board right now is not the answers. It's just,
I don't know if you realize what's happening, but
trying
I'm
to give
interrupting
names to the
myself.
things we were just looking for.
That was me interrupting me from another time in one of the videos that's being, all right, sorry. The second level is this. Let's say, so some people have already gotten 50 points for the day. And again, like they could leave if, I mean, that would be dumb. But from the standpoint of this game, they could leave now and their work here is done. But now we're going to discuss some physics, right? And we're going to, I'm going to throw a question out, and the basic rule is going to be, we're not going to move on until I get a right answer. It may be easy, it may be an exercise, it won't be a trick, but whatever the next thing is, which frankly is going to be problem H of part 1 of the math methods homework assignment, I'm going to throw out a question, and I'm just going to wait until we get the right answer. That might be right away, because one of you might have been dying to say it for hours and are bored stiffless, so you'll just say it right away, or whatever, or it might take a little while. I will not help the discussion, but once we get a right answer, I'll say, yes, that's right. You're amazing. Could you please explain? Blah. Now, anybody in that discussion who says anything, this is the complicated part. If you say anything at all, you already submitted for 50 points to Portal 1. But now, in addition, if you happen to say something to which I respond either, yes, that is right, like that's the right answer to the whole deal, or that is a right step, everybody should like do that step, and yes, that will advance you, whatever. If I say like that claim is correct, you can take that same statement and submit it now into the second portal. Like literally one contribution can get doubly dipped. If you say anything to which I say, yes, that is right, that's helpful to the class, you get an extra 50 points. But also, if I say that's wrong, equally you'll get 50 points. If you say anything at all that is gutsy enough or specific enough or concrete enough or like concrete enough, verifiable enough, that is subject to me either saying that is right or me saying, and hopefully I'll be polite about it or whatnot, but me saying, no, actually, like, and I'll probably say like, no, that's good and that's helpful, but actually that's wrong. And I may or may not tell you exactly what's wrong with it. But if I say it's wrong, you still are going to write it down and say, and submit it to the second portal for an additional 50 points. And again, I'm saying, if you say something that's gutsy enough that I literally can say that is wrong, you literally can take that statement that you made, just write on a piece of paper and submit it to 2 different homework portals for a total of 100 homework points. And I'm dead serious about this. We're going to start it now. And I started the other classes and I really think it's going to help. Again, people that are quieter or whatever, at first are not going to love this. It may force them to be a little less quiet, but if someone is truly super engaged and listening all the time and really caring, but super, super, super quiet for whatever reason and doesn't even want to type in the public chat, they can talk to me in the private chat in the chat and set up an appointment. We'll figure something out. This is to get everybody engaged. Not everybody's a talker. I know that. But I will certainly wait. The public chat is equally, like, I don't care whether it's in the public chat or talking. But the main thing I really want everybody to know how serious I am is I don't care if it's wrong or right, but if it has the guts to be either one, then it does get additional favor. Wrong is as good as right in physics. Wrong things that you know are wrong are more important than right things that you don't know are right. Wrong statements are steps forward, and like all of us are way too worried about saying things that we think are wrong in public, and it slows us all down. So the reward system is you say something that could be right or wrong, like whether you know it or not, you get the 50 points, but not if you put it in the private chat, by the way. Private chat is not for that. Like, we want to wean ourselves of that habit. It's for like private stuff. Not like, I'll still listen if you put it, but I won't give points for it. So I'm like, I don't know if this sounds harsh or uplifting, but it seems to have had an uplifting effect in the other classes. We're going to try it. We're going to start in a second. Again, it's already begun because anybody who has already said anything can already submit that to Portal 1. I guarantee you. But can I get an electronic show of hands that you basically get what I'm saying, how this is going to work? Thank you. Cool. That was really fast. Thank you, Steve. Thank you, Brianna. Thank you, Rain. Thank you, Durkel. And by the way, do I say Durkel or Dirk? Can you pronounce your name?
Yeah, it's correct.
Oh, I'm saying correct. Okay, Durkel. Okay. So all you guys, and do I say, sorry, Ms. Bones, can you say your first name so I don't say it wrong?
Jovalise.
Jovalise. Okay. Thank you. And all of you, notice that's not an accident. Like, I'm going to try to use this as a way to use your names more and more. I promise you, every time this will give me an opportunity to use people's names in a way that I hope they get. If I use their name at all, it's because they just did something right. Like, they just said something, which I consider right. And the more I use your name, the more it means I know you. And it's just better for both of us. And we can cut through the garbage and all that. So I apologize in advance. I'm going to start, but I'm not ever using someone's name to draw them in and call them out. That's not why I'm doing it every time. Like, another connection is made so that person could be more known by everybody else, blah, blah, blah. So cool, cool. I'm feeling that you guys get it, what I'm saying. Oh, I don't know, look at the chat. Okay, fair enough. And I appreciate that you put that in the public chat. So I think you'll catch on. I can't, and maybe one of your classmates could maybe explain it and summarize it in the chat, but I'm basically just saying from here on in, if you get explicit points for explicit participation, like, and I'm not saying, like, for example, Isadora, if you're a little bit lost, what I'm literally saying is, since you had the courage to say that in the public chat, since you wrote in the public chat, I am lost. Tonight, you can literally write on a piece of paper, just remind me, I'm the one that said I'm lost, and you will submit that as your PDF for the assignment portal called A Game Take One. That will just be a reminder to me that you said something in this class today, and you will get 50 points for that. That's the larger point I'm making, is that people, okay, oh, cool, all right, you got it, cool, thank you. And you definitely would get 50 points now. See, like, now I feel that you understand me, and you feel I feel like something's going on now. It helps everybody, so cool. All right, so we're gonna start this, but now the flip side of one thing I'm saying is we're gonna do this way, this method is, I'm gonna now tell you the next question. Sometimes it'll be directly from the homework, sometimes it won't, but I'm just gonna throw the question to you guys and expect you say whatever you want, however you want. You don't have to raise your hand, just like talk amongst yourselves loudly or in the public chat. Just try to solve the question, take big steps or small steps as you like, but when you get it right, I'll say, yes, you got it. Until that time, I will try to say very little, but I'll try to keep you in the right direction, but I will not really help until, and if someone says something wrong, again, they're still gonna get totally 50 points. So, there's no like, you get it. So the first question, honestly, I'm gonna actually I'm gonna share, hold on a second, what we're doing right now. I think I can do this now. Right, so I hope you can confirm. I think your screen just shifted because I think I even can annotate. Yeah, all right. Oh, wait, sorry, hold on. So hopefully you can see, and maybe you can confirm in the chat, or can someone confirm with voice? You're looking at the math methods sheet right now, yes? Like it's screen shared correctly? Could someone say yes or no? Wait, can someone make a noise so I know I can hear you? Did I lose you?
Yeah, we can see it.
Okay, thank you very much. Oh, and yes, okay, so I just lost the chat, I'm sorry. Okay, so we're there, and I'm just doing it this way for a moment, just to make it absolutely clear that, if I can do this, So experimental, okay. I'm saying where we are, if everybody can see this, okay, this is sloppy, but this is the question at hand. And we're just like continuing on with the homework, okay? And I'm literally saying now, first, our question at hand is part H sub I. This is not whether you actually did it and submitted it or you're figuring it out now. I just want the answer to that. So you guys, as soon as you say it or you put it in the chat, I'll tell you if it's right. So you can take as long or as quick as you want with this, but we'll move on once we get a right answer. And sorry, when you get it right, I will probably ask you to explain it to everybody, but yeah, so like to anybody who wants, just take it. Well, I'm gonna stop the share because I don't know. I'll rewrite the question on the next sheet, but so again, we're all just, yeah, I'm just gonna wait for someone to say something about this.
So I got negative omega over e to the omega times t.
Awesome. That is very nice. First of all, yay. Second of all, you're going to remind me that you're going to write down a piece of paper, but I don't even, was that Muhammad? I'm not even sure who said that. I'm sorry.
It was Robert.
I'm sorry. Oh, Robert. Okay. So, and you get it. You're not like, as an example, even if he was wrong, what he just said now was either right or wrong, right? Like he just proposed an answer. It was that concrete that it was what we call a claim. It was literally either false or true. I'm actually applauding and saying it's true, but I want everybody to understand he's going to write that on a piece of paper and remind me, and he's going to double dip. He's going to put in both assignment portals and 50 points for each. But that's great. But now, as far as what he said, let's just make sure. So if we're all on the same page. Oh, and I'm going to write what you just said, but could you just explain like which rules you used or like how did you get that, either in words or you can share a screen if you want, but Or could you remind me, Rob, just remind me, what's the exact, what's the original function? Y equals, or X equals?
E to the negative omega t.
Okay. And you're saying this.
No, I said, well, I said, I said,
Oh, sorry.
oh,
Sorry.
yeah, I guess that's right. It's, yeah, negative omega over e to the omega t.
Oh, wait, no, I just made a mistake. I'm sorry. Wait.
Yeah, that.
Okay. No, and I appreciate that you're being careful of this. Wait, so we both, this second thing I wrote, we're both agreeing it's equivalent to what you said, but is it what you said? What did you actually say? Is that what you said?
That is what I said, yeah.
Okay, great. Okay, so to everybody, yeah, first of all, right. I mean, he and I both just took a beat there because, you know, either way of expressing this answer is fine. But just to make it clear to everybody, this works. His answer is correct because he had to do two things. He had to know the derivative of the exponential function in general, and then he had to apply a chain rule. Right, and then he got an answer which can be expressed one of two ways. These are two equivalent expressions, and it is good to know that. I'm going to break this down one step further to make it clear, because this is a good review from yesterday from the chain rule. This is assuming. In general, if y equals e dx, then dy dx equals e dx, right? And he's number one, he's assuming this super weird and super unique property of the exponential function. Like he's correctly deploying the fact that the derivative of e to the x is exactly e to the x. I mean, it's the pure form of something that is self-differentiable. Like the cosine upon differentiation does get us back to the cosine, but it does take a couple of steps and it does throw in a negative sign and a constant. Right here, the exponential just returns precisely itself upon one derivative. That is such an exciting property of it that arguably it is in fact its essential feature. Like that is what the exponential function is the thing that does that or means that. But so he's using that, but he's also using chain rule, right? Also, he's using what we said yesterday, that same thing we said yesterday. What you do when you have a function of a function, which we do because it's not e to the x strictly there, it's e to the negative something times x. So the negative comes out and the something comes out is the point. Okay. So he's totally right. Now the reason this is coming up, like it does seem like why are we suddenly like doing this math, is precisely because we're thinking about this Hooke's law, the physics Hooke's law, is motivating us to think about functions that are self-differentiable, functions that embody feedback or capture feedback, and the exponential function is such a function. So it's coming to mind, and we're deciding to play with it to see if possibly it might be as useful as the cosine in analyzing simple harmonic motion. We're going to go to the next question now. I'm just losing this sheet. Because again, this whole cosine thing that we're obsessing over, and we're going to continue to obsess over, this cosine thing is super important because it's a solution. But what we just found yesterday was that it's not, our first version of it is not the only solution. It's just a solution. So now we're looking for others. Okay, so we got, all right, so somebody else, okay, sorry, I'm talking way too much. Could somebody else, so he got 50 points. Okay, somebody else just bring us to H2. Could anybody else tell us either the answer or a step or whatever to the next derivative? Okay, so I'm looking at the chat. Thank you very much, Stephen. Awesome, awesome. And I think awesome. Awesome. Yes, I totally agree. He's totally right. Right. I'll try not to drag out. He just did the exact same thing again, so I'll try not to drag it out. He did chain rule and exponential again, but this time now, notice the negative sign comes out again, so we get, right? So it's like looking like great. Also, oh, thank you, Brianna. By the way, okay. So first of all, thank you, Stephen. Just to be clear, again, Stephen now, and I'm not trying to extol these, but I sort of am. So Stephen now is going to submit this reminder of this twice, the exact same reminder in 2 places, get 50 points. But also Brianna, I just want to say this to everybody. Notice Brianna's also now saying she got something similar, and you arguably you could say she's saying it after or something. This is not a race. There is no buzzer. She totally also gets credit for saying that. I mean, for 1,000 reasons, even if she literally wrote the exact same thing as he did, and then is trusting me to know that she just happens to be a slower typer or something, still, I wouldn't care. I don't care if she is or not a slow, it's not a race. It's about people saying stuff. So yeah, if someone says something and gets 50 points for it, if you're listening enough and you realize that was a worthy thing to say, and now you want, as long as you're being authentic and you now get it too, or you get something about it, people can echo each other, and it's totally great. So so yes, I agree with Brianna's answer. Also, I do agree with the answer. Who cares? Well, we care. I mean, so good. But now why are we playing? So we're playing with this now, this function, because we want to bring it back to physics. It really is about bringing it back to physics. So we go to part I. Whoops, sorry. We go to part I. And now that we've taken 2 derivatives, we can ask ourselves the actual question is, and this is the question, is therefore, looking at what we did, is this a solution to this, i.e., does it describe a harmonic oscillator? Okay, so it's a yes or no question with a why or why not. Anybody want to say anything about it? Go for it. Ah, cool. Okay. I'm looking at the chat. Sorry. Okay, fair enough. Again, by the way, Brianna has already totally gotten her points. So if there was a fight right now, if I got 3 different comments at the same time, I might look at a comment from someone who hadn't said anything at all just to make sure they got their points too. But now, okay, now notice now Brianna is saying something concrete and gutsy. She is actually saying yes or no to a yes or no question. So she's either going to be right or wrong. Same thing with now Rain. And Rain's even oh, wow. Okay, now we're getting somewhere. Because I think it's, so now some people are saying yes, some people are saying no. People are actually having the guts to disagree with each other in class and not feel like anybody's going to break over it, which is great. So someone's going to be right and someone's going to be wrong, but everybody's going to get points for this. And then it just got more specific. And I will say the right answer, since someone has said the right answer. Right. Ultimately, the bottom line is the answer is no, and it is what Casey said, and Casey's going to double dip now too and get 250 points. And Brianna's going for the O, which I like, which helps. Yeah, I mean, I would actually qualify slightly and say that to Casey's thing, I think I would say it isn't because it isn't negative. In other words, well, right. So the answer is no, and this is important. We are not just doing random math exercises. Every exercise we do, even if it's really mathy, is to try to get at something in the physics. What's happening now is we're playing with exponential functions to see if they satisfy the differential equation. If so, then they could be used to describe oscillators and bring us more insight and prediction power to oscillators, blah, 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 blah. And E feels like it would be the kind of function that should be able to do that because it generates itself and you do. But what we're finding is, I'm agreeing with Casey and Rain and so forth, what we're finding is no, even though E feels like it should, or at least something with E should work, so far it's not working for us. This particular example we tried, this example that we're trying, this conjecture, does not And this is very important, okay? Because this shows you it's a really important question. Like, is blah a solution to a differential equation? Is this function, does this function satisfy a particular differential equation? Is a question that comes up all the time in math and physics. It's like saying, if we know these physical facts about a system, can we infer this? Can we use this rule to predict what it's going to do? We're always trying to match the answer to the question. Now, you have to know what it means to say yes or no. Like, the way we get these solutions a lot of times is we guess them, but then we test them. We believe it because we believe our test, but we all have to understand the test. Here we have an example where we have a function, we took two derivatives of it. It looked very much like what we were doing yesterday or 2 days ago with cosines and stuff. It like looks like the answer is going to be yes. It looks like all the same math, but in the end of the day, because in this case with this particular function, in the end of the day, what we got was this. After we differentiated it twice, we got that. Like, if you look back, and I'll go back to that page again, but if you go back to the page, we took our function x equals e to the negative t. We differentiated it twice, and we got this. Remember, we're assuming, or we're trying, x equals e to the negative t. So what we got today, when we were testing this thing that looked good, it looked really reasonable, but we got here that when we differentiate it twice, we get, yes, we get itself times a constant, but not times a negative sign. Not times a negative sign. What the oscillator equation, what the Hooke's law equation says is there literally is a minus sign in that equation, and it makes all the difference in the world. It means it comes from the restoring force. It's that minus sign in negative kx. If there's no restoring force, there's no oscillation. Something just goes on forever. So far, in other words, exponential, this detail really matters. We're being that technical. Like, there's no difference in X or Y or Z. There's no difference in A, B, D. Like, we're being really fast and loose about certain things, but super picky about this minus sign. It's got to be there after two derivatives in order for us to have captured an oscillator. Okay, so anyway, again, everybody's going to get the points based on, right? But I'm going to go on. So the answer so far to I is no. Now let me go back to what, and anybody can stop me at any time with any question, or can you go back a page, Yaverbaum? That counts as 50, seriously. Or just say like, wait, I missed, or wait, what, or like anything. You can just stop me and either tell me to go faster, or anybody that stops me and goes like, you could please move on to the next problem, like that. Anybody who politely controls my speed, that counts too. But right now I'm just trying to find the sheet again. Sorry, I'm losing the sheet. Okay. So the next question is, oh, all right, now we did all that. Now the math goes up another weird level. Like, and I could totally more and more looking at this sheet now and more understand why. I think it was Robert, like, you know, raised the thing about context and stuff. Like, yes, we're sitting here taking derivatives, then suddenly there's an exponential function. It seems completely random and unfair. Like, why is there an exponential function in the middle of my physics homework? And now I'm introducing imaginary numbers, and I'm not denying it. Suddenly now I'm introducing imaginary numbers, which are super cool. But first of all, you might say, if they're imaginary, what the heck do they have to do with physics? Second of all, you might rightfully say, wait, I've always heard about imaginary numbers, but I've never taken a class and I don't know how they work or like what I'm supposed to do with them. Like, what do you want me to know about imaginary numbers and what the heck are they doing here now? Well, first of all, just part of it, that's all fair, but just trust. I mean, if you just go with the assumption that things are coming up for a reason, it helps quiet some of the fears. But as far as imaginary, yeah, I'm going to bring up imaginary numbers now. You're going to see why in a minute. But what do I expect us to know about them, or what am I doing with them, or what? All I'm saying about them is exactly the one thing that everybody does know, the defining characteristic. I'm just saying from here on in, let's give the name I to the quantity square root of -1. Like, I don't really even care if I stands for the word imaginary, or complex, or any of that stuff I don't care about any. I'm just saying what we do all know is if you multiply a positive by a positive, you get a positive. If you multiply a negative by a negative, you get a positive. So if you're looking for what the root is of some positive number, it could be a positive or a negative root, right? But if you multiply a negative by a positive, you get a negative. I mean, but the only way to get a negative is multiply a negative by a positive, and a negative and a positive are not the same number. So in the system of numbers that we have on the number line, the real number line, there's no way to find or place or conceive of what it would mean to be that thing which multiplied by itself gets a -1. I don't know what it would be, but I don't know anything about it other than if it were to exist. I don't even know if it exists. I just know that the idea now exists in my mind, so I give it a name and I call it I. I equals the square root of -1, and that whatever that is. And that's all I need to know about it if I just now assume that the rules of square roots and negatives and everything else applies, right? And that's what we're going to do. And now again, why would I even introduce this? Well, partly, the main reason I would introduce this actually is because of an exercise that I'm now, okay, wait, I'm going to give you a sidebar exercise right now. Like I'm going to insert something right into the homework right now. I'm going to ask everybody to do, and we're going to do the system. Like you'll just do it until you get it right and you get points and all that. So before we do this side, well, oh, sorry. Okay, so here's what we're all going to do. Again, we're done with this as soon as someone gets the right answer. But to put in things in context, like what we just found out in homework in part I was that e to the -ωt doesn't work, doesn't describe oscillators. And it doesn't work because the negative sign doesn't do what it's supposed to do. So the reasonable thing, if we were invested in this and we were looking for a solution, a very reasonable thing to try next is, oh, since the negative sign was the problem, the negative sign wasn't working, well, let me try not a negative sign, let me try positive instead of negative. So let's just do the natural thing of trying the other alternative or the another option, which is let's try x equals e to the omega t. My question is, if you tried that, does that satisfy d2x dt squared equals negative omega squared dx? Like that's my question to all of you. It's again a yes or no question, but once you say an answer, sort of someone's gonna have to explain it. But that's my question for now. Like, take it. And I'll write it again on the next page, more big, but I'm gonna write the same exact question. But that's the question now. And it's not on the homework. It's a sidebar. The homework said x equals e to the negative omega t. I'm taking out the negative sign. So huh. All right. Yes, totally. Okay. That just saved everybody some agony. Absolutely. What Robert is saying is absolutely right and absolutely right. And I'm not even going to, and I won't belabor the point. I will write down what he just said, just so we can see. He's totally right. And that there's nothing better I could say about it, but I will write it so everybody can see it. He's totally 100% right. And what point does that make, besides that he just got like 400,000 points? And by the way, if this game thing works and it's working for people, and I want, if it works more and more, I will make a more and more complicated point structure so people get more and more points for more and more things, whatever. But the point is that we feel like E should work somehow. We try it in a simple way, in a simple form, the negative gets screwed up. So then we try without the negative, still doesn't work. So when negatives and positives are both not doing something for us, like -1 is not the square root of -1. And also +1 is not the square root of -1. When we get in a jam like that, we think, I wonder if there's a number in between, could we call it I? The same jam is here. Like we know that we have an intuition or a hope that something could work, but the whole real number line from negatives to positives seems to be trapping us. So we just see if we can try. So this is just, I'm just explaining why I would even come into anybody's mind. It certainly doesn't prove that it's right or it'll do anything, but why it would come into our mind is because we're trapped between positive numbers and negative numbers, and neither one seems to, both of them seem jammed up by the rules of negative and positives. So we consider jumping off the real number line to the complex plane, so to speak. And with nothing more than that definition, we say, okay, so this is back to, this is now back to the sheet. I'm going to turn it to you guys again in a second to tell me the answer, but I've just lost the sheet. I'm sure. Oh, that's a point. Yeah. Okay. So there's oh yeah. Duh. Okay. Given now, we're just considering this function. Oh, and I'm going to turn it to you guys. Oh, but one thing. So what do you need to know about I? You just need to know that it is the square root of -1, whatever that means, meaning that it is a number which, if you squared it, you would arrive at 1. I mean, that's what we need to know. But one other thing to know about it that's actually super important here is we're calling it a number. Note that it is a number. Whatever kind of number it is a constant number. So whatever the rules of differentiation are, or calculus, apply here to I as they would to any number. Treat I as a constant, not a variable. And with that in mind, anybody who wants to tell me anything about this next question, you know, J sub lowercase I, what's the derivative? And obviously it would be preferable if we go someone new, but I'm looking for any kind of, and you can be doing it now. It's not, again, even if you didn't do, you could be doing it right now, but any thoughts on where we are? Here's a 50-point opportunity. Raise your hand electronically if you hear me right now. Cool. Okay, cool. Thank you, Casey, Beyond, Rain, Yovelis. Oh, I'm still learning how to say it, Jovelis. Cool, Isadora. So each of you, by the way, for that, like Camille, who I didn't see before, Camille, you now have the 50 points just for doing that. Thank you. Same but now all those of you, so thank you. But now raise your hand if you know. I'm happy to take as long. I want people to take as long as they need. But raise your hand if you know what it is that you're trying to do right now. Raise your hand if you know what the task is. Okay, cool. Cool, great. Okay, and I'm not even asking if you know how to do it. I'm just making sure. All right, so then take your time. And again, talk amongst yourself. I mean, pretend like you're in a breakout room, except for the good part, not the bad part. I will only praise something if it's right. I will get 50 points if it's actually wrong. So if you have an idea, you might. But yeah, cool. And Novelis just got 50 points. Although if she has an idea, oh no, I take that back. Yeah. Okay.
So I said I have an idea, but I actually don't have an idea. I feel like it's radical -1 e to the I omega t.
Yeah, actually.
I don't know. If
no, actually, yes. Wait. Yeah. First of all, that was super specific, and that was definitely more than just an idea. That was exactly right. But I'm missing one letter, which you might have just been a typographical error in your speaking. It was just missing one letter, but it was exactly right than that. And the one letter is the letter that is in what Casey and then Hyung John, which I'm pronouncing wrong, Ms. Kim, both put.
Oh, so we don't have to substitute the I for the radical -1.
Right. I mean, you can leave it either way. I mean, you're allowed to just leave it as I, but you wrote it as square root of radical -1. You could write it either way. You just don't have to. You can leave it as I is the point. And right. No, well, Casey, what you actually did correctly was you treated it as a constant. That's what I sort of want to say and I'm going to write it down in a second. But Rain, like this is a perfect example. It feels like maybe you don't have an idea or you've never done this before, but if you just trust that I is just a number, like if you just pretend that I was just like the number 3, you treat it that way, then you all view the people that are talking right now, right, as a constant, right? Right. What was I saying? Right. As long as you just pretend that I is 3, like as long as you don't get intimidated that it happens to be a letter, just like we've gotten used to understanding omega is a weird new Greek letter. It means something weird, but as long as we recognize it's just a number, then we just treat it like a number, and we're getting used to that. I'm saying now is the same thing, and you can just literally leave it as I because people know what it means. So I'm agreeing. So it's just chain rule, like all these guys are saying, and everybody who just, again, like some people, and I appreciate, like obviously I'm getting to know who Rain is just in general, and that's great. But like, and so she's definitely got the points and all that. But also these people like Casey, Durkel, I'm sorry, Ms. Kim, how can you say your first name so I can say it right?
It's
Yeah, okay, it'll take me a little while. But those people, like, so they just got 50 points. Thank you. Like, and I'll get to know them better now as a result. And even if one of them even made a slight error, which I don't think they did. Oh, cool. And thank you for the okay. It makes sense. Cool. Yes. Oh, and now, and I think Durkel is bringing us along to the second one, which I'm totally going to accept. So I'm going to catch up. I'm going to write down the correct thing that everybody just said, and then move on. So actually, I just forget, was this the question? This was the question, right? Yeah, okay. So that is the answer to that one. And then I'm going to assume that what Durkel is doing is just moving us along to the next one. And I think he's right. Like if you do that again now, if you trust yourself and just do it again, the I comes down again. So we have I squared. The omega comes down again. So we have omega squared. We have the e to the I omega t. And that's correct. But now notice something I can do to make it simpler. This is correct. Like if anybody wrote this down, like they'd be correct. But notice, if I by definition is the square root of -1, even if we don't totally know how to picture what that is or what it means. One thing we know for sure about what it means, if I is the square root of -1, then what is I, and this is a 50-pointer right here, what is I squared equal to? Definitely. Yes, thank you. That was fast, Ms. Kim. Thank you. I'm definitely getting to know you now. Yes, and that's super important. This is like always the way math works is people don't realize what we're always doing in math is we're collecting the stuff we know and then we're attacking the stuff we don't know by giving it labels and names to make it seem like we know it. Like we call the crap we don't know X and then we solve for X. We don't know what it is, but by calling X, we can command it. And then at the end, we get a value for it, like 5 or whatever. Same thing here. Like you look at a problem like this and you might think, I don't know what's going on with I. But you can hone in, and I is just a name for the stuff you don't know. And once you give it a name, it obeys properties and reveals the stuff you don't know. Anyway, so I squared is -1. Therefore, the best way, you would still get full credit, anybody on an exam or whatever, for writing what I have up here. But the best way to simplify this answer now, then, right, the best way to express it instead of I squared is just write -1, which is to say -1 times the whole thing we already had, so negative omega squared. And if we do that, you might see where this is going. I think you see where this is going. If we do that, well, I'm just going to jump to the chase here to get, that was, yeah, if we, then we do that and we go to K. Sorry, just checking the time. Well, I'll throw it at you. Yeah, so if we now go to K, what's the answer to K? Does this exponential solution work, yes or no?
Yes.
Yes, awesome. Yes, totally. Like, and this is actually a discovery in the history of math or physics. Like, it's again, it all seems like just arbitrary weirdness, but what we're saying now is, oh, wait a minute, what we're really saying is, hold on, oscillator, something that goes back and forth. If it goes back and forth forever, what that really means is like all of its rates of change are going back and forth forever. Like something, a mass on a spring that swings back and forth, or a pendulum bob that swings back and forth. What we're really trying to say here is it's more than its place that swings back and forth. Its speed also swings back and forth from like high to low or high to 0 to high. And its speed swings back and forth, acceleration. And its speed of that swings back and forth. Like something that's swinging back and forth has all of its derivatives also continuously at the same time running and swinging back and forth. It's actually quite elegant. And the exponential function seems like something that should be able to describe that. But exponential functions tend to always go one direction or the other, like exponential feedback up or exponential decay down. How could you have an exponential function describe a back and forth thing? It seems like somehow weirdly, if you combine imaginary numbers with exponential functions, we can capture the same things that cosines can. That is actually a truth, and it's a big, weird breakthrough. It's why complex numbers actually are. They're not imaginary. They actually are used in physics in a very big way. I don't want to get too sidetracked, but what I'm saying, I'm agreeing with Rain, and I'm losing weight. Okay, I'm agreeing with Rain that the answer to K is yes. Yes, if X is equal to not e to the blah t or not e to the negative blah t, but e to the I omega t, then d2x So the answer is totally yes, what Rain said. Now I'm going to ask you guys, I think we're going along here. Oh, sorry. And that's important. I want to say more about that, but that's the point is now, it's another way of saying our cosine thing that we're going to keep using in physics, our cosine expression, our cosine position function is a good descriptor of a harmonic oscillator. It is not necessarily the only one, or it's not even necessarily the best one. Like there's other ways to describe. What it really means in the end, well, you could just, here, I'm going to say one thing. This is a very, in other words, exponentials and cosines are very, very different, but they can be linked together through the use of imaginary numbers, which is a very big surprise, but a very powerful discovery and a very powerful indication of how not imaginary numbers actually are. Why, how do we use this in physics, or why would this even, like, again, why would this occur to someone? Just notice one thing, please. Or wait, what time is it? Yeah, I'm gonna, no, I will ask you to notice one thing in a second. Let me just turn this back to you though and ask, before I get too crazy. We just did, right, we just did K. Right, we just did K. There's no such thing as L. We're done with this part of the sheet, which is great, but I'm gonna now ask all you guys, what may be the natural corollary? Like we just showed that if X equals e to the I omega t, then that actually solves our problems and it works. Let's make sure and see how weird or self-consistent this is. I'm now gonna ask you all, consider again, you might already guess where I'm going with this, and you're probably guessing correctly if you are guessing. Consider X equals e to the negative I omega t. Like, would that work if the Bosnian work? The question is, does this satisfy That's the question for now. Again, this is a yes or no question, but then just give some kind of explanation and that will be cool. Great question in the chat. Yeah, it does apply. It totally applies, but make no mistake, but you don't have to use it to do, like, you can figure this out by just doing the exact same thing we just did a second ago. In other words, the Euler thing is like a name for what we're seeing right now. You don't have to, I think it would be harder to try to use it directly to figure this out than just do exactly what we did a minute ago and just see. So yes, Euler applies, but you don't, that's a side, consider that a sidebar. That's just the name for what we're doing now. You don't have to use that. Awesome. And yes, totally, Rain is totally right. Yes, it totally does. That is awesome. I'm not even gonna ask her to explain it because I think like, in other words, what we're saying now is, that's awesome, we're about to go on. So this question, I'm not asking you guys, I'm about to show you, okay? So I'm saying I is actually a powerful thing in physics. It's not to be dismissed, and it's not to, one shouldn't be intimidated by it. It does open up whole things, but one reason that I comes into play and helps us describe, it helps us capture the same thing that cosines do when you put them together with exponentials is, notice this. And please write this down. It's going to look so. Okay. Okay, what's that? Yeah. Okay, this is a little bit illegible. I don't use, so usually when I say derivative, when I talk about derivative, I usually write dy dx. I usually prefer that notation. But right here, for a purpose, for a moment, I'm using that old-fashioned notation that some of you know from other math classes, where if I say like f prime, I mean, like I'm saying, I'm using f prime to mean derivative, again, for a reason here. So like I'm using f like 1 to be equal to the first derivative. And I'm saying like f2 equals the second derivative, etc. Now I'm saying, notice, let's take the cosine function and just investigate it for a second. If you take one derivative, if you take no derivatives, you have the cosine function. If you take one derivative, you have negative sine. You take two derivatives, you get negative cosine. Three derivatives, you get positive sine. Right? Yeah. And four derivatives, you get back to cosine, right? So 4 steps, you get back to the original, right? Everybody know that? Okay, now note this, and I can turn back to that page if anybody wants, but that page was just writing. Now note this. If f of x equals e to the x, well, then not surprisingly, again, it seems like I'm just silly, like just writing things for busy work. I'm not. I'm trying to make a point. I'm saying, first with the cosine thing, if you run it through 4 derivatives, you'll get back to itself. With the exponential function, if you run it through 4 derivatives, you'll get back to itself. Now, clearly, you don't have to run it through 4, right? With the exponential, it's easier. You could just run it through 1 or 2. But the point is, if you let 4 cycles go by, it will be the same place as if 4 cycles is the minimum you need to have both of these functions back to where they begin, right? So you can keep the exponential in step with the cosine if you go through 4 steps. And now, as at a minimum, it's like the lowest common denominator or something. But now note this. Here's the connection. Oh yeah, in fact, I'm gonna turn this to you guys. This may be the last thing we do today, and that's okay. But let me ask you. Sorry. Right. No, great question, Rain. So what I'm saying is so far, only cosine and sine functions, well, the only functions I know that go back to themselves after 4 steps are cosine and sine and e to the x. Like that's exactly what I'm saying is not all functions do this. Like most functions don't do this. Most functions like 1/2 at squared, and I'm saying this to everybody. That's a great question. It's great. And again, if she had said nothing this entire class, like that would totally be such a contribute, but she did. But anyway, like a typical function like x equals 1/2 at squared. That's a x as a function of t. Now that one, if you take a derivative, you get a t. You take another derivative, you get a. Take another derivative, you get 0. You'll never get back to the t squared, never ever, right? You crash down to 0. Tons of functions in the world are like that. You take derivatives, you get simpler and simpler functions until you just get a horizontal line at 0. Some functions you differentiate a few times and you get back to themselves. The only functions we know so far, and this is what we're saying, we are saying to ourselves, oh, sine and cosine seem to be that way, where if you go 4 steps, you'll get back to themselves. And e to the x also seems, if you go 4 steps, you'll get back to itself. Again, with e to the x, you don't even have to go all those 4 steps, but guaranteed, if you go 4 steps with e to the x, you'll get back to itself. So far I'm saying those are the only functions we know. Like tangent does not do that. And arctangent does not, et cetera, et cetera. But now look at this I thing. I'm going to ask everybody, maybe not Rain, but everybody else, what is, and again, even if you think you're just learning imaginary numbers now for the first time, all you got to know is imaginary is a number. I mean, all you got to know is I is a number, square root of -1. If you follow the regular rules of exponents, I'm asking anybody now, especially maybe someone who hasn't said anything, who wants some points, what, and again, you can be wrong, but just say something. What is I to the 0th power necessarily? Like definitely, what is I to the 0th power? And the hint is like, what's anything to the 0th power? Because it's not a trick. Yes, awesome. Yes, wow, that was so fast. That's great too. I wish there were a buzzer. We're gonna get a buzzer. Yes, Casey, Jerkel, Camille, awesome. So, okay, so good. Now, why am I saying that? I'll go on. And if we want to just keep going, if anybody wants to, and if you see where this is going, if you want to type it in the chat, again, it's not a competition. If you just do it, you'll get if anybody hasn't gotten points today, please, what's I to the 1? And there's a reason I'm doing this. It's like, what's I to the 1th power? By definition. Yes. Thank you, Yovelit. And I'm still saying it wrong, but yes. And thank you, Camille. Yeah, it's totally I. Like anything to the 1th power is itself. Now, what's I to the 2nd power? Even though I said it 2 pages ago, who cares? What's I squared? And again, could be somebody new. Yes. Awesome. Now, you might see where this is going, and you might have seen this before, just maybe not in the connection with cosine and e. So what's I to the 3rd now? This is slightly harder, but this you can totally get. Yes. Nice, Ms. Kim. Yes, absolutely. I to the 3rd is, I don't know what it is, but I know it's got to be I times I to the 2nd, right? So it's got to be I times -1. This is what she's saying. So it's got to be like -1 times I. So it's negative I. It is, right? This is how like we understand things that we don't understand. This is like what's great about math. Like it works like this. Like it figures things out for you that you didn't think. So now what's I to the 4th? Because this is like the point. I to the 4th, I'll give you a hint. It's either I squared times, yes. Now look, thank you. That was Ms. Kim, I think. Yes, thank you. And again, by the way, the point is not that I'm going to remember. I will actually remember. But anyone who said anything, you're just going to write it down to remind, so that and then you'll see the points in your good. Okay, I to the 4th is 1. So look, I'm just saying this is the connection between complex numbers, complex functions, exponential functions, and trigonometric functions. At least the simple ones. The connection is something about them. They all they all reproduce in 4 steps. With all of them, if you cycle through 4, you get back to where you started. Something about that ties them together in a very deep way. We are going to see more of them all. Right now, what it means is there's more than one way to describe an oscillator. What's the takeaway here? This is just like the slippery relationship between math and physics. Hold on. So far. So that's it. Wait, I know my handwriting is. Okay. Um, um, oh, okay. I'm going to say one last thing. I'm not going to ask any more questions right now. Again, it. I think this, for me, this felt like much more of a class. I hope it felt better for you guys. Anybody who, I hope it felt better for everybody, even if you didn't get tons of points or something. Hope this is going to, again, I have no rule. There's no rule against everybody in the class getting an A. Let me just say that again. It's in that sense, it is not a competition in that important sense. So hopefully the more people talk, the more it's helping other people talk. It seems like it's happening. I feel like the understanding is getting sharper. I'm just, so your assignment, if I don't put anything different in the stream or whatever, is just go to the next step of where you are. Like, I'm going to continue with this math methods sheet, then I'll go to the next sheet. I'm just going at that pace. You'll start getting stuff back soon, but just go to the next step, and you all can predict how my pace in class better than I can, I'm sure. But I'm going to leave you with one thing to help put this in perspective. I know it's very mathematical still now, and physics 204 is more mathematical than physics 1, because we're dealing with immaterial things. Ultimately, physics 2 is the motion of immaterial things, waves, fields, and radiation. So in a way, it all gets more abstract, less concrete. But now all of a sudden we're dealing with exponential functions in a very calculus way. But this whole e to the x thing sort of raises, let me put it another way. All the radians and the cosines force you to deal with pi again in some new way in your life. And this part is forcing us to deal with E. And it's a little bit easier to, pi, that number that goes on forever without repeat, is at least kind of easy to picture once you get used to it, to picture why anybody cares about it. Right? Pi is just like if you take a piece of string and wind it around a tree once, and lay that string down, or lay out that string on the ground. And then you take another piece of string, which just cuts straight through the tree from one end to the other, and lay that on the ground. So you compare the shortest distance between 2 points, the straight line path between points, to the perfect circle way around. You find always that one piece of string is bigger than the other piece of string by the same amount. Like, the diameter always will, always a little bit more than 3 diameters will fit into one circumference, no matter how big the circle is. That's the meaning of pi, right? The fact that for centuries people could say that they didn't know what the number is, or the fact that every year we get a better version of what that number is or something is interesting. It could raise questions like, wait, if they didn't know what the number is, had they know that they didn't know what it had, if they had a number, had they know it was wrong, like, what were they comparing it to? And the answer is, the ratio that people are always looking for is this. We call that ratio pi. But what is E? Like, E is harder to picture, right? I just want to leave you with one way to picture E. It is harder to picture, but there's one cool way to picture it, which if, as long as you're getting a little bit used to limits, you may, this really helped me a lot. And again, it may have been said to me at first, but it didn't sink in until way later. This is what E is. And I'll show you what I mean. Yeah, I have like 1 minute to just show you what I mean. And this right here, just say, this is not an exam or anything, okay? Like, you could tune out right now just for 2 minutes, just to try to give perspective on what a weird or cool number E is. Just gonna tell you, like, I'm gonna write on the next page. I'm saying this is what E is. E is the limitation of this process. E is what happens when you take something and add a fraction to it. So in other words, this is what I mean. And it's cool to think of it this way. If you let n equal 1, like, let's just try 1. If n equals 1, then E approximately equals 1 plus 1 over 1, which is like 1, right, to the 1. In other words, E approximately equals 2. Okay, now that's, you all know E is like 2.71, blah, 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 blah. So according to this, E is like something near 2. But wait, then try n equal 2. Then according to this formula, E would be 1 plus 1 over 2 to the 2, right? So that's 3/2 squared. That's like 9/4. 9/4 is like 2.25. Okay, a little bit higher than 2, right? You can see where this is going. I'm gonna do one more step and then we're done, just so you see what I'm saying. Just so you see the point, if you let, it's, to me, this is just cool. If you let n equal 3, then E approximately equals 1 plus 1 over 3 to the 3, right? And that's like 4/3 to the 3rd, which is approximately 4/3 is 64, 3/3 is 27. So that's like 64 27, and 64 over 27. And as I say, this is the last thing we're going to say together. 64 divided by 27, which I do not do in my head, is like 2.37. So look what's happening. What we're saying is, if you make n greater and greater, the value of E gets, see how E is getting, it starts at 2 and it's getting bigger and bigger. Like if I set n equal to 2, this is a better estimation, it's like 2.25. Then I set n equal to 3, it's a better estimation, like 2.37. The thing is, you can make n as high as you want, and you'll get closer and closer to that number 2.71, but you'll never get past it. This pad, like, so E, if you take this idea all the way to the limit of just 1 plus 1 over n to the n, that you'll get closer and closer and closer without ever passing the number 2.71. That's what the number 2.71 is. It's the limitation of this process. In other words, it's the limitation of, like, if, you know, instead of getting 25%, I'm not going to explain it. That's what E is. I'll just leave it at that. Good night.